Good afternoon. My name is Gladys Diaz, and I'm Associate Professor at the University of Paris XIII. And this work is made in collaboration with the Professor Miguel Ángel León Chávez at the Autonomous University of Puebla, and his PhD student Silviana Chalini in the same university. I present the UML model of a gateway for the interconnection of IEEE 1609 and CAN networks. This presentation is organized as following, and first time I will present the introduction of our context, and second point, present the approach that we have studied for this interconnection. Point 3 is the presentation of the gateway proposal, and I finish with the conclusion and perspective. Yeah, we situated our work in the case of the road safety. Road safety is a major society issue. In 2011, more than 13,000 people died on the road of the European Union. Thus, there are so many, the European Commission adopting an ambitious road safety program with a mix of initiatives focusing on improving vehicle safety and the safety on infrastructure and also the road users' behavior. And in the context of future vehicular application, new model must to be defined to enable the access and interconnection of existing control systems, in special to improve the vehicle and road safety. Thus, vehicle to vehicle and vehicle to infrastructure are two communication approaches to be considered in this context. A new service involved in the safety in vehicle and for the infrastructure could be implemented by using together these two types of communication. Thus, we are interested in the study two first approach to major approach in these both type of communication. That the IEEE, that is specified a family of standards to define the wireless access in vehicular environment, the wave. And the other side, we have the modern vehicle that interconnect all kinds of devices. By means, unless two types of network defined inside the critical and the comfort. This network can be implemented by using the controlled area network, the CAN, defined by ISO. CAN is a serial communication bus supporting distributed real-time control with a high level of error control. Thus, with both approach, so many working groups are defined, and we are interested in the 1609 working group that define all the architecture. Where satellite or cellular or sensing technology to communicate. IEEE 1609, this standard, but it's a family of standards that define the architecture, define a set of services located at different levels, and the interfaces to enable secure communication, vehicle to vehicle and vehicle to infrastructure by using the wireless communication. In the context, the primary architectural component defined by this standard are the onboard units, the roadside unit, and the wave interface. So different standards have been given in last year to try the aspect like the resource management, the security services for application, the networking services, the multi-chain operation, and all with the wireless LAN, the access control MAC, and physical layer. And wave device is composed by a stack of all these standards. If you compare with the OSIDE reference model, we can place the different standards, different level. By example, for all the networking services defined by wave, in the 1609.3 is corresponding to the services represented by layer 3 and 4 of the OSIDE model. The 1609.2 define the administrative function to support the core of security function like authentication, control information, by example. The lower layer are defined for the standard 1609.4 to all the functionality related with the MAC sublayer. And for 8.11p, we describe the function and the service to communication with wireless, but without authentication or disauthentication and privacy service. And the upper layers initially were defined with the 1609.1. Today is the without standard, and it describes an application to the wave device, an application by using some different entities. That we have the wave resource management, the resource command processor, and the resource management application. We have interesting in make the interconnection of CAN network and all these standards by using a specific node inside the CAN network, but placed an application layer. Donc we go to modeling in the next step, modeling all these entities and show how this entity can communicate with the CAN node inside of the vehicle. So many different drafts with draw standard had been defined to specificate all these different functions at different levels. And this figure shows an example where you can see the different entities that are involved in the context of wave communication. Sorry. I am stressing. I begin, if I can. Yeah. Well, the different entities defined in the wave system. You have the roadside unit, that is a fixed entity along the road. You have on site the onboard unit on site in the vehicle. And the wave communication technology enables to provide communication between vehicle and vehicle infrastructure. In this case, we can see that you have an accident in the highway, and the idea is that the vehicle involved in this accident can communicate with a critical message to the infrastructure, and the infrastructure can distribute this critical message to other vehicles in the highway, or maybe to signal also to guide to the driver to say you must to change lane or you must to exit before this accident. In this case, in this fashion, we can avoid the complication with the accident highway. Well, in our proposition, this paper proposes a gateway at the application layer to make the communication between the CAN node inside of vehicle and the IEEE 1609 onboard unit. Possible application of the gateway is to perform the functionality read and write operation between both networks by using potential collision message, not only as a warning message, but also maybe to control, with control message inside of vehicle to device control, maybe the ABS, for example. The other side, we have the CAN network, okay, defined by ISO. CAN define two or side layer, that's a physical data link layer. The upper layer are no standardized, but there are several commercial proposals on application level also. Yes, so different specifications have been given for control area network to data link, physical signaling, or specific transmission rates, or time trial communication, for example. Ouais. Donc, we present here the proposition and gateway for interconnecting both networks. We place our proposition on application level when you have interesting in IEEE 1609.1, and we go to modeling all the different entities involved on this level to represent the different communication that must to be placed to make the interconnection. That 1609.1 specifies the communication between the resource management application and the resource management, as well the communication between resource management that can be located on the roadside unit or on the onboard unit, and the RCP, this last is hosted in the onboard unit. But the communication between the RCP and the internal network of the vehicle is outside of the scope of this standard. And we have proposed in this paper and gateway at application layer of one CAN node to serve as an interface between the RCP and the CAN network. The goal of the gateway is to perform the read and write operation between both networks. This slider shows the different entities involved for this interconnection gateway. And roadside environment, the resource management application that communicate with resource management. And the vehicle environment, the RCP, resource command process, and the CAN network, and the gateway is situated like an interface between both entities that manipulate the CAN ID table. CAN ID table contains the different identify for different messages at inside of CAN network. And the data that can be exchanged between RMA and RCP can be made between read and write operation with transfer page that is controlled by RCP. Yeah. This transfer page provides an interface in onboard units to make the communication between the external entity with the on-site network CAN. And so this definition had to be modeling. like we can find the CAN's IEEE 1609 protocol entity that manages the writing and the reading requests for CAN network and wave device. We define the CAN ID table with the values for different messages in the CAN network. The CAN ID table can be accessed by the gateway. We define some different proposed primitives to enable the communication between the gateway and the RCP. The read from CAN, write to CAN, read and write. We have used the UML language to modeling of all these different entities and to represent the interaction between these entities to represent finally the gateway proposition. Thus, I show some of these different models. The first is the use case contextual diagram that show the different big operations to be considered in our system and the major actors involved in this system. And for second, we have the class diagram. We define here all these entities like by using a diagram of class. Here we can see that gateway proposition is composed by the two entities, the CAN IEEE 1609 protocol entity and the CAN ID table that make the gateway between any other CAN node IEEE level and the RCP that control the CAN transfer page. Voilà. Donc, we define as methods all the operations needed to represent the different exchanges, the different interaction between all these different entities. And for each use case in contextual diagram, we have defined the sequence diagram to show for each functionality in our system, the different interaction between among the entities. This is an example for write to CAN. In this case, we have the RCP that send and write CAN request to the protocol or entity gateway with the ID and value. The protocol entity send this request to the CAN LLC node inside of the CAN network. And this entity waits for an ACK for this treatment. When it receives the ACK, it sends a value, the new value, to the ID table and send an ACK to say that write to CAN was OK. The same for the read from CAN. We have defined this interaction between the different entities. Here we receive the CAN gateway protocol entity receive and read from CAN with the ID of the message from RCP, and he can access the CAN ID table to retrieve the good value for this message and to give this for the RCP. Write to set a new value inside a table, the CAN ID table. In this case, the node inside the CAN send and write to the gateway protocol entity with the ID and the new value. Our gateway can access the CAN ID table to actualize this value inside in the table. Well, this paper has presented the model of a gateway for interconnection of the control area network and the IEEE 1609 standard. we defined in our proposition the CAN application protocol entity and the CAN ID table that conform the notion of gateway. We have modeling by using UML language, all these entities involved with this gateway by using the use case, the class, and the sequence diagram. This gateway is described by using unified developing process and language. And the goal of the gateway is to use the potential collision message not only as warning message for a vehicle, maybe for automatic take control of the vehicle in some security or critical situation. The future work, the real-time and security analysis of interconnection is not made. This is in the future work, also implementation, test, and simulation of our model. I say thank you for your attention. If you have any question, I can try to answer.